Alright guys, in this video we're going to be showing that the Maxwell's equations will form a wave equation and form wave equations by doing some interesting math. So what are Maxwell's equations? These are equations that describe electricity and magnetism. We have up here that the divergence of the electric field is the charge density divided by the permittivity of free space. I always get that mixed up. And then we have the curl of E is the circulation about a point in the electric field is the negative of the derivative with respect to time of the this is I'm sorry, I'm drawing a blank. I'm doing things too fast. Let me slow down. This is the magnetic field. Yeah. And then the curl of the magnetic field is, the divergence of the magnetic field is 0. And the curl of the magnetic field is proportional to the current density, J, plus the also proportional to the derivative of the electric field. That was a lot to say. Basically, we're going to be sort of trying to combine these equations. We're going to have two equations at the end. Some notation stuff when I write this d subscript t and then to like whatever power right here. And that's the same as just the partial derivative. The reason we're going to be needing that is because we're going to have to be moving things around. Hey, camera, can you focus for me? Thank you. No. Hey, camera, can you focus for me? Thank you. And the other thing is that a simple identity. Hey, camera, focus. Hocus pocus, focus. I don't know why the camera doesn't like me. But basically 1 over the square root of epsilon 0 mu 0 equals the speed of light. That's just an identity. Rho is the charge density, J is current density, blah blah blah. So next thing that we're gonna need is a little identity, and I have a brief proof here, but I might make a full video going over the identities for the product rule with divergence and curl. But basically we have that the curl of A, or I like to call it the double curl, but people get mad at me whenever I do that, is the gradient of the divergence of A minus the Laplacian of A. Oh, and another notation thing is that this capital delta is also the same as nabla squared, which is also the same as the gradient of the divergence. So brief proof, we have we write it the first cross product with the epsilon notation, or the permutation notation. So that's just a definition. That part's just another definition. That part's just another definition. This part's sort of some evaluation, rearranging stuff, and then using definitions you get to here. So it's basically just, definitions, then rearranging stuff. All right. So now we're basically ready to move on to this. So what we're gonna do is we're gonna take the curl of this first equation, and we'll see what we get. We're gonna take the curl of the curl of E equals the curl of the negative, I'm going to just write it like this, dB. Alright, so now notation, this, we're going to write it in this term, is now the gradient of the divergence of E, then minus the Laplacian of E. That equals, I'm going to move this around, and I can do that because of some identity stuff, but basically I can move this derivative, this operator, around, and now I'm left with this, and then curl B. Right? Camera, can you focus? Yeah, close enough. I know it's like super blurry, but the camera just doesn't like focusing. Kind of like me doing tests. So next thing that we're gonna do is factor out the, or no, before we factor out the E, we're gonna replace some stuff. So divergence E, we noticed that from earlier, is our other equation, which is the rho over epsilon 0. So now we have the gradient of rho over, or times, I guess, 1 over epsilon 0 would be a better way to put it. And then minus Laplacian of E equals negative. And we saw that the curl of B dt, we have this equation right here, which is a mu 0. Oh, thank you, light, for flickering. Mu 0 j plus mu 0 e0 t, or I can also write it as 1 over c squared, and then dt, then times e. Right? So now we just gotta do some rearranging. I'm gonna distribute some stuff. I'm gonna move, let's see, what do I want to move? I want the e's on one side and the non-e's on another. So I think I'm gonna move this over here and this over here, right? Does this make sense? I'm gonna move this Laplacian term over here and this j term over here. And what we get is 1 over epsilon 0 gradient rho plus, this turns into a plus, the mu 0 I can move around because that's a constant, and then we have dt of j, right? Yeah, and then this will equal, I move this over here, this is Laplacian e plus 1 over c squared d e. And I guess I can change notation from that now. It doesn't really matter too much. No, actually, no, I'm not going to change notation, because then we're going to factor out an e, I guess. But that's basically the equation. We're basically already done. Can just rewrite it a different way. This should be right, though it could be wrong. I'm just doing this on my first take. If it's wrong, I'll delete the video and make a new one. Yeah, so that should be right. Hey, camera, can you focus on this? Here. Right here. Okay, I'm spending too much time trying to focus. It looks like you're looking through glasses or something. There we go. Stay like that. Stay. Alright, if you move, camera, you're getting disowned. Look how clear that looks. Alright, so the next part of the problem, so that was our first part, our A. Then our equation B we can get by doing the curl of the other one. So let's do the curl of B, right? Oh man, I'm gonna have to move this up here, right? Equals, well, from our identity, mu 0 j plus mu 0 epsilon 0 dE dt. Oh man, I should have opened the whiteboard just to make sure this was right, but it's sort of whatever. Curl of curl is, why am I short-circuiting? This is gradient of the divergence of B minus the Laplacian of B, which equals the, oh wait, this should be curl right here. So we're taking the curl of this whole term, and we're going to distribute that, and I can move the mu 0 out because that's a constant, plus this is 1 over c squared. I can move the this thing around, the dt, and the curl distributes in. We get curl of E. So I know I did a lot of steps there. I'm not doing an amazing job at explaining this, but I hope you can see that if you just move some things around, then you'll get to this right here. So divergence of B is 0. We saw that. That's just one of the equations. So, and then the gradient of 0 is just 0. So this goes to 0. Now we just have negative Laplace B equals all this junk. And we're basically done. Oh wait, no, we're not done. How on earth did I forget? So we're going to go now. So now we have negative, or no, we're near done. Well, I guess we're like halfway there. Curl J plus 1 over c squared dt. The main reason we did this curl E is from one of our equations earlier, we know that that is negative dtb, right? So now I'm going to move this term to this side, and we get 1 over c squared. I'm going to factor out the b at the same time. dt squared minus Laplace on b equals mu 0 curl j. And so now we've got our combined equations. This one and that one. I'm going to just bring this one right here, which is that yeah, it's Laplace plus 1 over c squared dt. Shouldn't that be a d squared? Hold on. I'm going to make a quick check. Always do a quick check. Yeah, it should be a d squared. Because when I distributed, I forgot. So that's why I wasn't 100% sure about it. So where I went wrong there was up here. I didn't distribute completely. And I don't think I distributed the negative. That is a cardinal sin. I have sinned. Don't worry. I make mistakes too. So this should be a negative sign right here. So it should be Laplace minus 1 over c squared d squared t e equals 1 over epsilon 0 gradient rho and plus mu 0 dt j. So these are basically in the same form. You can just like factor out a negative sign. Hey, camera, focus. Hey, camera, focus. Trying to focus too hard, I guess. So if we just factor out a negative from this term, that is what will get us into the wave equation form that we want. And yeah, that's basically it. These two equations we got from using some identities. Hey, focus for the last shot. And then that's how we got it. So I hope you somewhat enjoyed this really scuffed video. Like I said, I'm just making videos for fun right now, but I'll hopefully make some more serious videos in the future where I actually, work on teaching stuff. This was just me sort of doing an exercise I did on camera. So yeah. See y'all later.